wanted to give you one more quick example for dealing with cells in the CoLab environment. In particular, we're going to play a little bit with variables here. So let me go ahead and create a new notebook. So that's the file menu there. This is likely placing this into your default CoLab notebook area within your Google Drive. I'm going to call this variables.ipynb. And let's go ahead and add a little bit of a header here so that you get used to including that. Okay, so variables in Python are dynamically typed, meaning that they are defined really at runtime as we're doing assignments. So there is no explicit declaration of variable types. So A implicitly ends up being an integer, B ends up being a floating point value. Once I execute that cell, these two lines of code get pushed out into the underlying Python environment, at which point the state of the environment changes. So now I can ask what the value of variable A is, what is the value of variable B. There is also, like many languages, there is some sort of a print type of command that we can use. So print gives us similar kinds of outputs as we saw up above. We can also, of course, do operations where we do appending. So if I ask it to print A and B, what it does is it converts A to a string, prints that, and then converts B to a string and appends that to the end of A. So we end up with a 5 space 2.7. Likewise, we can include strings in here. Python, there are really two different notations for strings: the double quotes or the single quotes. At least for in this context, the meaning is identical. So I'm just going to add a basic string and then our two variables, and those three things will get appended together. Okay, so let's do a little bit more. Let's add a bit of text here. Oops. So this is the pound is marked down for header level 2. And we'll just say strings. So I'm going to assign a new variable, and I'll use the single quote in this case. Just call that foobar and execute that. And I can print that. I can also print things in this way. So again, str or colon is going to get appended onto the value of C. That append is really implicitly happening it's being done by print, but I can also use the string append operator, and that is plus. So if I have two strings, I can append those together, and I end up with essentially the same thing, except one fewer spaces here. However, I cannot do something like this. In some languages, sorry, I want a plus here. In some languages, knowing that this plus operator is being executed in the context of a string, what that means is that this object here should be translated into a string first. Python does not do that for you. But instead, what you can do is explicitly tell Python to convert that object to a string, at which point it does what we would want. Okay, so like all good languages, we can also have formatted strings. And I'll go ahead and print this out. And the first is we're specifying the format string. So I'm expecting an integer to fill in here, a float to fill in here, and a string to fill in here. So the way to push those in is to provide a tuple. So this percent operator takes this tuple and pushes those elements into the string here. So then we explicitly get the values for A, B, and C. Like good formatted string languages, we can also do things like this, where we say I want to have 3 decimal places exactly, and I want to put zeros on the end. So in this scenario, we've got all these extra zeros. I'm going to chop off some of those. So there's our 3 decimal places at the end. Okay, so last quick example, we're going to do some Booleans. So variables can also take on Boolean values. So true is a literal that we can assign to a variable explicitly. And then we can do various operations on that. So I'm just going to print out a value. I can also, let's write a few lines of code here. Oops. And then we can print E. And given that A has a value of 5, then this E is taking on the value of false. Let me give you one more example to kind of make it clear how these cells are interacting with underlying Python environment. So this variable A we defined further up toward the top of the file, but I can further down the line, I can reset that value. And as soon as I execute that, that changes the value of the variable, at which point, if I re-execute this cell, that new environment state is the context for executing that cell. So I get the 1 here, and if I print out E, I now have a true value here. So so the things to keep in mind here are that just because you have code in cells doesn't mean that they've affected the state of the underlying Python environment. You have to execute them, and one cell can override the state that was set up by other cells. So that's something that's useful in some contexts, but also something to be a bit cautious about. And as we start to write more complicated code, we're going to start encapsulating things using functions and classes, and we'll talk about that here soon.